Audio Jungle. Audio Jungle.
Hello everyone, welcome to the 8th International Congress of Genç Ekonomistler. I'm Yasin Tosun from the University of Zigan, and I will be moderating this session on the last day of the congresses. Our guest speaker in this session will be Professor Kerem Coşar from the University of Virginia. He will be presenting his article, The Baltic Exchange, Weather Risk and International Trade in Early Modern Europe. So following our presentation, we will have a question part. If you have any questions, please send them to us via the YouTube chats. And thank you, Professor, your participation after this Congress again this year. And if you want to say anything, first of all, we will wait to your opening after the sessions.
Yeah, no. Teşekkürler Yasin, and to all those who are organizing and attending this online. Thanks for inviting me, and I look forward.
Okay, and now we will begin. So this presentation is here.
Okay, let me move my slides up to this screen. And let me first tell you what this is about. I'm an international trade economist, and I work with both current as well as historical data sets and settings. And this is one, as the title suggests, is from early modern Europe, roughly 18th, 19th centuries. We're going to look at a 200-year span of trade in the Baltic region and North Europe. And you may wonder, why is this relevant for today? This is going to be about food security in some sense, and weather shocks. And with climate change, this is increasingly relevant for today's world, as I will tell the story about some of the trade policy implications of this period, as a result of which there were serious famines. This is a cautionary tale for today, because one of the things that countries resort to when there's a major shock, either a shock like COVID or some weather shock that drives food prices drastically, is to either restrict exports if they are exporters, in some way impede trade. It's one of the instincts of policymakers, and these distort markets and lead to unintended and unnecessarily harsh consequences. So we'll get to, hopefully, to that at the end in the qualitative section. So to get this going, my co-authors here are a colleague here at UVA, Jonathan Colmer, and Simon Alder is at the Swiss Bank, as well as Swiss National Bank and University of North Carolina, Chapel Hill. There's this disclaimer here at the bottom about none of the views here represented are officially those of Swiss National Bank. Okay, so I think I described what we're going to do. We're going to look at this grain trade in Northern Europe for about 200 years, from mid-17th to mid-19th century. Let me skip the preview of results and get to them as soon as possible. So just to also give an academic background, what is new here and what literatures are we contributing to? There is an increasingly popular line of research on climate and trade. The general takeaway in this literature is, there is enough food going around. We like, not the entire humanity will starve, but there could be regional shocks. In some years, some locations, some countries may be undergoing a drought or a bad yield in their harvest. In those cases, they import, right? That's one of the things that trade does. It's a mitigation strategy. You buy and sell to match supply and demand. So we contribute to that literature. And typically famines, there's this idea that famines are a human-made phenomenon. Typically people, of course, prices respond and merchants step in. You import if you need to. You credit for it if you can. And unless there is some policy screw up, we don't see famines. Almost all, I don't know of any exception, of at least modern famines are artificial in some sense. They are human-made screw-ups of policymakers. All right, so these are the relations to two major literatures. There's also an economic history literature debating the extent of market integration in early modern Europe. And to that literature, we contribute with this relatively underutilized data set called the sound toll register. I'm going to show you the map in a bit and tell you what the sound is and what registers we are talking about. All right, so historical background. So we're talking about this strait called the Sound, the Öresund Sound, between Denmark in the south and Sweden in the north. It's a narrow passageway that controls the entry and exit in and out of the Baltic Sea from northern Europe, northwest from the North Sea. Since the Danish crown for a long time controlled both sides of the strait, after a while, of course, Sweden acquired the southern tip of the peninsula. But even after that, the Danish crown continued levying a transit tax, a toll, on the ships passing through the Öresund Strait. So when we zoom in, this is Copenhagen. Sweden is here up in the north. There are two major passages, the Stora Belt in the south, the lines here, the one to the left is the Stora Belt, the other one is the Öresund. These are very narrow straits. There's no way you can escape. In some sense, smuggling is not possible. This canal here, Kiel Canal, is a modern thing that was built after the toll ended in mid-19th century. And the overland trade is expensive. So in some sense, for any bulk trade of the sort we will be talking about today, for grains and wheat and rye, for any of that sort of thing, overland smuggling is prohibitively expensive. So you have to sail through this Öresund Sound, and then you're visible. No ship can escape. There's this fort with cannons, and if they give you a warning, if you don't stop to pay the tax, they shoot a cannon at you. So it's as good as enforcement can get. And then they stop the ships. The ships report their cargo, what they are carrying, where they are coming from, and where they are going to. So for the period we will look at today, the amazing thing about these records, very meticulous, as you can see, these are these big ledgers where the officials of the day, with their handwriting, recorded this origin port, destination port, and the cargo. And of course, details about the valuation of the goods and how much tax is collected. This has been analyzed before by historians, before digitization, before this sort of digital humanities revolution has taken place, in tabular summaries of the data. So no rigorous econometric analysis has been done on it until recently. And then an institute in Netherlands has digitized this and made it available publicly. This can be scraped. It's a searchable database, but we also got the cleaned data, more or less clean data from that institute, on which we had to do a lot of work ourselves to clean it further. So let me show you the data a little bit. Again, each observation here is a cargo item on a passage with a recorded date, so you know the exact day of this passage. After 1668, almost all passages have origin and destination ports. For some reason, they were not asking these systematically before, so it's more scattered in the years before. But after 1668, we can link origin and destination ports. We know the quantity for the grain, so how many kilograms that is, how much wheat and rye and barley and so on they are carrying, the value, tax status, and other details. So we cleaned the place names and the commodities. We classified them into modern categories. So at the end, when this whole business is finished at 1856, and it's finished because it's the era of free trade, the British are not very enthused about this tax, and they urged the Danes to stop collecting this. And after that, there are no records because there's no tax collection. So we have more than 1 million passages and about 3 cargo items in each of those, so about 3.14 million cargo items, line items, for this roughly 200-year period. The map here with all the red dots in the coastline of Western Europe are the ports that are reported either as destination or origin. There are way too many to be operationalized. We're going to aggregate them. So there are about 1,617 ports, but it's a very skewed distribution. The top 40 of those ports account for 80% of the passages. So what are the top 5 ports? Amsterdam by far is the largest. Most of this trade is done by Dutch ships and Dutch merchants, which is why the institute that I mentioned that has digitized and publicized this data set, it was in Netherlands. Amsterdam is the entrepot, more or less. Modern day Gdansk in Poland, historical German name Danzig, that city is a major exporter of the grain out of the Baltic to the west. So that's the second largest port. Riga, again, modern day Baltic city, St. Petersburg, and then finally London. So all well-known places. We aggregate these ports to the level of European Union nomenclature, uniform territorial system, NUTS regions. So now the red dots that you are seeing are the ones that we will work with. For instance, within England, we will have, within the United Kingdom, we will have 5 ports, 4 in, 1 in Scotland and 4 down in England. Most of the action is going to be between the Baltic and Western Europe. Nevertheless, we kept some French, Spanish, Italian ports here as well, but they're relatively rare. And then we have made the shipment quantities of rye and wheat uniform, so they are in kilograms. So we know exactly what quantity of those 2 commodities are carried. And then for a subset of these ports, we have price data. So that comes from the work of Bob Allen and Unger, the Allen Unger Global Commodity Price Database. This is a standardized database of rye and wheat prices in terms of grams of silver per liter in 117 European cities. Sorry, it goes beyond Europe. There are some in North America as well, up to 1826. So we match this with our data set. So basically about 34% of all serial shipments, right? The large towns in our shipment like London, Gdansk, the prices in these ports are reported continuously. So it's a pretty good coverage. About 1/3 of all serial shipments in our data are matched to this origin and destination price. Finally, we bring into this a really interesting, let's not say forecast, a backcasted estimates of the weather conditions in Europe during this time period that comes from the work of climate scientists. It's very high resolution. So for like a 50 by 50 kilometer grid from 1500 up until recent, this should be 2000 Common Era. There's annual, actually not even annual, seasonal. Okay, so like the growing season and then the harvesting season. We have temperature as well as rainfall. Okay, so the way they estimate and backcast these records is from about the last 150 years, there is actual records. Like we actually do know the measurement of temperature and rainfall from most places in Europe. So they calibrate models using these actual records with the repositories of information in nature for climate events like ice cores or tree rings and sediment records from the bottom of lakes, For instance, tree rings are the major source here. A tree grows more in a year with plenty of rainfall and normal temperature. So a thick tree ring in a certain year, they can tell, they can go backward from, say, today. The previous ring is the previous year. So you go 300 rings inwards, you are 300 rings before. And you can tell the thickness of that ring, how much rainfall and temperature must have been realized that year for the observed growth of the tree. So based on the modern day records, they calibrate these models and then in some sense extrapolate based on the repositories in the nature. So here's how this data looks like. So this is a standardized plot of temperature. For instance, 1.5, the yellow, right, where Turkey and Eastern Turkey is, that's 1.5 standard deviations above the average, long-term average, in spring of year 1695 for that region. And then look at Northern Europe, right? The frigid, you can see it's like all blue, deep blue, that's -3. So it's like a 3 standard deviations below average temperature for that season for those locations. I'm showing this because this is a well-recorded year of a frigid spring, a very cold spring. So the data confirms historical records, right? Like in a year like that, people have written down, wow, that was such a terrible winter, so much snowfall, and such a, there was so much ice cover. It's all in the records. We will see the famines that are associated with this weather event, and the data confirms that. Similarly, 1741 was recorded to be a very wet summer. The rain never stopped and there was flooding. You can see in Poland and parts of Scandinavia, we have 2 to 3 standard deviations above normal rainfall in that year. This shows us the time series. The red is the average summer-spring precipitation, and the sort of max and min bands are in the gray. Similarly for temperature. The years that I mentioned, if you look here for 1695, there's a big dip. That's the frigid summer I was talking about, some frigid spring I was talking about. All right, so now let me show you some descriptive patterns and facts from the data. So first of all, this is a good period for the analysis. Just to give heads up, where are we going? We have quantities of traded, we have prices, and we have these supply shocks, right? So a bad year in terms of weather is a negative supply shock for yields. So we're going to estimate a 101, a textbook 101 level supply and demand framework, right? In international context, export supply and import demand. Why is this a good time period to study this? Well, first of all, there are no big changes in transportation and communication technologies. It's a pretty straightforward environment. It precludes major demographic transition and major effects of industrialization. Later in mid-19th century onwards, there's this phenomenon called grain invasion from the Americas. Imported grain from North America becomes really important. This period precedes that. And you can think of it as a competitive market, whereas the long-distance trade in exotic goods and colonial goods were dominated by state-supported monopolies. Here, a lot of small-scale Dutch merchants are pretty competitive. So the textbook case should hold. And then increasingly during this time period, although Amsterdam is still an important entrepot, we have a lot of bilateral routes. So not everything goes through Amsterdam, right? If that was the case, we wouldn't be able to say, well, this destination needs to import wheat because they're having a bad harvest. But if they're buying it from Amsterdam, we wouldn't see that in our data. We only see things that are going through this strait and recorded as originating from a port in the Baltic and destined to a port in, say, England. So there's increasingly more of these direct linkages rather than intermediated trade through Amsterdam during this time period. Top products, we're going to leave out most of these. We're going to focus on cereals, which is the third most important westward product, but wood is important. So most of the British Navy uses timber from the Baltic. In the eastward direction, so these are West Europe's exports to the Baltic, we see beverages. Most of that is wine and brandy and rum, textiles, manufactured goods. So basically you have commodities being exported out of the Baltic in exchange for manufactured goods imported by the Baltic region. These are the number of yearly passages. This big dip here are the years of Napoleonic Wars, right? Everything comes to a halt. Otherwise, there are seasonal variations. There's another dip in 1700 to 1720. That's what's called the Great Northern War, a major war between Sweden and Russia. Again, that's a year of depression, but otherwise, there's an upward trend after that all the way to the end of the data. At the end of the data period, by mid-1800s, we're talking about 15 to 19,000 annual passages. So it's a large-scale trade, 3,000 passages in the early periods. And most of the trading is done between when the ice is thawed from April to October. So in those 5-6 months, they carry either the recent harvest, if it is a Baltic export, or plausibly something that was stored from the year before from storage. These are wheat and rye exports, the tons of grains. Rye is the important commodity here. As countries get richer, wheat becomes also exceedingly more traded. And then I mentioned the Dutch Republic back then is the major carrier of this. With the rise of Great Britain, we also see the number of there's tons of grains that are being shipped to either of these countries. Great Britain eventually catches up and becomes an important importer as big as Dutch Republic and from mid-1700s onwards. All right, just to give you an idea, how important was grain exports from the Baltic? Because you may wonder, if you're going to talk about famines, is this an important source of nutrition and calories for these people? Well, the Dutch Republic especially urbanized much earlier than the rest of Europe. By 1668, let's say, by the beginning of our data period, the urbanization rates in these lower countries, in Amsterdam, Rotterdam, was pretty high. About 10 to 15% of total calorific intake of the people there were accounted by these Baltic grain exports. So it's pretty important. It's not the majority, but it's an important buffer against local crop failures, right? 10-15% of your nutrition can be the breaking point between starvation and survival, depending on what happens to local output. What we did to our data set is to subject it to a couple of quality checks, to a couple of smell checks, something that empirical researchers should always strive to do. Never trust any data source, try to cross-validate them with each other. So we took UK statistics on wheat imports, and we correlated it with our own sound toll data. So official data is in red, our data is in blue. You see how well they correlate. So that's a good external validity for this data. We did another one on bilateral trading relationships for the 1826 to 1856 period. Data starts being reported for increasingly more importer-exporter pairs. So each dot here is, you can see the names, like let's say the one on the right top corner, Russia, Great Britain. So that's the official data in the x-axis for log trade flows in Great British pound from Russia to Great Britain. We correlated this with what we have, number of passages between these two, again, you can see the high correlation at the pair level for this period of the data set. Check 2, also done. Our data is reliable. Now let's start looking at the price data real quick. What would you expect from a trade perspective? Is the origin price to be lower than the destination price for the same commodity, because there are shipping costs in between. So this Ellen Unger database gives us the rye price for rye. I think it's yulaf in Turkish, in current British pound. They move together, right? This is more or less an integrated market. As you can see, the ups and downs correlate, but also the Amsterdam price, which is the importer, the destination, uniformly higher than the origin price, the exporter from Poland, which is what you would expect. And the gap should be informative about the level of trade costs and shipping costs between the two. We did another check. There is one more data set that I didn't mention, constructed by 2 Swedish historians, Olsen and Svensson. These 2 economists have found records from a number of farms in southern Sweden from 1700s. Okay, so they constructed this very high quality data set of, I don't know how many animals were there in these farms annually, what was the yield, and a bunch of other things. So we checked the correlation between our rain data, the standard deviation of rain from average in the x-axis. Each observation here is a year, so we kind of average these farms for the region, and then the percentage yield deviation from trend. So for all these farms, yields are per acre yields are kind of growing, but there are variation, ups and downs around that trend. So our rainfall data, right, years with low rainfall, I highlighted again some catastrophic years here, like the 1783 that are well recorded. They have a collapse of yields in the order of minus 20-30% from trend. So this was descriptives. So now let's start estimating this textbook model of supply and demand. We asked 3 questions. These correspond to different dimensions of the panel data that we have, right? So the panel data, again, is a origin destination pair of varieties of grain, mostly rye and wheat, in each year. So first we look at the cross-sectional correlation. Do regions with more rainfall correlation trade less cereals with each other? And I'll explain why we ask this particular question. The second dimension is the time dimension. Is there less aggregate trade in years when there's higher spatial rainfall correlation? And then finally, the entire panel dimension, do origin destination rainfall shocks affect quantity being traded? So let's start with the first one, the cross-sectional. So here we have on the left-hand side log cereal quantity, so tons of cereal. This is the sum of rye and wheat, I believe, or maybe just rye, but I think here we are summing them. Total cereal quantity from origin to destination in year T. And on the right-hand side, we have the distance between origin and destination, which is, of course, time invariant. But also all the right-hand side variables here, there are 2 specifications. There are 2 ways we have quantified this rain correlation here. This is a cross-sectional thing. There's no T subscript on that, because basically we're looking at the correlation over time in rainfall between any pair of towns, origin and destination. Okay, so it's a single number. And it's the time correlation, like the correlation between any 2 places over time. So the prediction is, if you are very correlated, you are subject to good or bad shocks, more or less, at the same time. That reduces the need for trade, right? Trade of this sort exploits differences. Like you need to have some heterogeneity, some differences for an importer who is having a bad year with heightened import demand to be able to import from an origin, an exporter that is having a good year, right? So you need that kind of differences to facilitate or to have any scope for trade. So as you see, either a dummy that captures like high rain correlations, so 0 and 1 based on the percentiles of the correlations, or just the raw number, the rain correlation itself with squared, the higher that correlation, the lower is the trade, where we have origin year fixed effects and destination year fixed effects to capture their overall supply and demand shocks. Okay, so as you see, like distance actually becomes insignificant in the second correlation. In general, we know that longer distances, fewer trade, but here the rainfall correlation is basically capturing everything. Now let's go to the time dimension. So this spatial correlation varies over time. Certain years it's idiosyncratic, certain years it co-moves. So we would expect, again, same idea, less trade in years when spatial correlation of rainfall is high. So this Moran's I is a statistic. It's a spatial correlation measure. The first one we did in the previous slide was a time correlation. This one is spatial correlation. In time periods that display basically a regional shock. So think of this as if the entire Northern European region is on aggregate having a drought, nobody has anything to sell, right? So again, just by this restricted supply, although some places will have high import demand, there's just not enough export supply. Again, we have less cereal quantities traded in those years. All right, now let's look at the origin destination level links, ODT, back to having quantity of cereals on the left-hand side. And on the right-hand side, we have the temperature or rainfall, both contemporaneous in that year T or in the previous year, T-1, in the destination. I'm not showing you what's happening in the origin because none of those coefficients were significant. So basically, we don't see a response of trading to what's going on in origin. But whenever the destination has a drought, a high temperature, or a low rainfall, we see increased, here, as much as drought, most of these yields are driven by what I've shown you, a frigid spring, a very cold weather. So the lower the temperature in the destination, the higher the cereal import demand. Similarly, the less the rain, that's the drought, the less the rain, the higher the cereal going to that destination. So that's what I meant. This is a clear supply shock to local yields in the destination. Whenever the local supply curve shifts inwards, your import demand goes up, and the signs are confirming that. So what have we found? Regions with high rainfall, they trade less with high rainfall correlation. They trade less with each other. When there's more spatial correlation in rainfall, when the entire region is subject to a similar shock, again, there's less trade. And then finally, pairs respond to destination weather. Whenever destinations are subject to a negative shock, they import more cereals from the Baltic. Okay, so far we've used only the weather data on the right. Now let's see if all this is consistent with prices, right? Moving closer to the supply-demand framework. Now we're going to have quantities and prices together. So this is a simple OLS regression of, again, cereal C type. So I think now we have the fixed effects. Remember, here we break down rye, wheat, and barley. So there's cereal origin destination fixed effects. So they have pair fixed effects. So the fact that some pairs trade more with each other in every year is captured by this. Now we're looking at the time variation, right? So the only thing that is varying on the right-hand side now is the T, because we have CD fixed, OD fixed effects already. So here we have either the destination price or the origin price, as you see, the origin price, consistent with what I've told you in the previous slide, is not responding. The second column, that's not a significant relationship. In the first column, we see the destination price. Whenever that's high, there is more cereal going into that destination. So what do we learn from this? Well, when you run a regression like this, quantities on prices, there's simultaneity bias, right? Are we estimating a supply curve or a demand curve? Both of these are endogenous. Well, if you get a positive coefficient, that means somehow you are recovering the supply curve. You're tracking the supply curve. But because of the simultaneity bias, the coefficient you get here does not truly represent the elasticity of supply because of the simultaneity. It's attenuated towards zero. So that's OLS, basically. It's the endogeneity. So what do? We need a good instrument for our price variable. That's where we bring in the weather data again. So let's find this exogenous supply shifter. All right. In this case, for instance, if it is a local supply for the destination, that's going to give us an unbiased slope of the export supply from the origin. So the moment we do that, see, this is the first column is now the instrumental variable regression compared to this one in the previous slide in OLS. The coefficient increases from 2.7, the elasticity, to 13.7. So this is a huge increase, which is consistent with the OLS being attenuated towards zero, being biased downwards. But it also shows us a very elastic export supply curve. Okay, and the other one remains insignificant. That gives us an inelastic import demand curve. So that's how we read those two things. A graph would have helped. I don't have it in this slide, but basically think of this as we're looking at a supply curve that responds very elastically to destination prices, and otherwise an import demand curve that is quite inelastic to what's going on to origin prices. All right, so what do we learn from that? Why is this interesting? Well, if you think about grain, it is a storable commodity. We've been looking so far at contemporaneous trades, right? Year T weather and year T shipments, but you may have year T-1 harvest still sitting in your granary if you saved it. So if the origin, for instance, in Poland, they had a bountiful year, they had a great harvest, they may not sell all of it, right? Or the destination, the Dutch in Amsterdam, may want to exploit cheap prices because of this bountiful harvest in Poland, import a lot that year and store it at the destination in the granary in Amsterdam. So why is this interesting? Well, the elastic supply curve is consistent with storage at origin. So basically, like, you must have some enough inventories to be able to meet this moving import demand curve rather than storage in the destination. And our historical reading is consistent with that. Basically, grain storage is labor intensive, but it's also land intensive. Land is expensive in Amsterdam. It's cheaper in Poland, where urbanization rates are lower. And also, to keep grain from molding and from infestation, you need to constantly somebody has to shovel it around. You have to air it. You have to keep it moving. Today, they have these machines and equipment within granaries that keep tilling this grain. Back then, it was done manually, and manual labor is again much cheaper in Poland and in Russia than in Netherlands and Great Britain. But another interesting thing about the destinations is whenever there is a shortage of food in these very urbanized areas, people riot and they storm into the granaries. Of course, the merchants are the scapegoats. They are the ones who are hoarding in their view, and people basically just go and storm these storage facilities. So that's kind of like a tax. So you can think of this as another cost component for the destination in these very urbanized areas, whereas in Poland and Russia, there is still serfdom. People are oppressed. It's not very urbanized. They live close to land, so there's not that urge to pillage urban storage facilities. So this is it. So far, where we are in this project is, in this last part, we are simulating a model of optimal commodity storage and trade. So we will have some structural explanation for this. Hopefully, we will quantify that model and simulate it to show that it can rationalize the qualitative story that I've just told you about. Elastic export supply, inelastic import demand, a model again with rational expectations and storage, we think is able to rationalize that. So that's where we are. Let me finish with the qualitative analysis of famines. There are 3 well-documented famines during this time: the Scottish famine of 1690s, the Great Famine of Estonia, and the Irish famine of 1740. So we read into these episodes and tried to understand what went wrong. First of all, you see the temperature shocks in all of these events. So we looked at our data to Scotland. This is the period of the famine. Indeed, you have a temperature dip. It's a frigid spring, winter, spring. Similarly, in Estonia around those years, and in Ireland in 1740s, like -2 standard deviation drop from average temperature. Okay, so the data confirms that there was an actual basis for this major food shock to these places. These shocks are also more or less regional, so a lot of other places are affected by it, which is why we'll talk about the policy responses in other places. So what happens is, in each case, you can find a policy that exacerbates these events. So basically, if the policymakers had not intervened and let the markets function, there was enough food, presumably, to be traded and to keep people away from famine. In the Scottish famine, we can blame the Dutch. They have an export ban, so they have stored grain. They get this imports into Amsterdam. They're the ones doing the trade, so they ban their traders to sell out of Netherlands. They hoard everything. Probably not all of that was needed, but again, that's not factored into policymakers' objective function. The Estonian famine, another story. This time, the Swedes back then were the rulers of Estonia. This is the Swedish Empire before this Great Northern War. Sweden mandated whatever was still harvested to be exported to Sweden to make sure that nobody at home is starving. So this is basically just appropriation, right? So again, there's a policy that disrupts the functioning of the markets. And then in the final case with the Irish famine, we can blame the British, the UK Navigation Acts that basically prohibit bilateral trades. Everything has to go through London. It's similar to the first one. Basically, all the train that the British traders were carrying, rather than going directly into Ireland where prices are high, people are willing to pay a lot of money not to starve, everything had to be imported into London first, which drives up prices and presumably stored there rather than being exported. So again, this is our cautionary tale for today in terms of intervening with the functioning of the markets. The couple of slides that I will skip are basically confirming that we do see in our trade data reduced exports or increased exports out of these places during the famine. Okay, so wrap up. Trade appears to have played a major role as an insurance mechanism against weather shocks in early modern Europe. The markets seem to be fairly integrated and well functioning, except when protectionism intervenes with it, which in many cases leads to catastrophic consequences. And for today, yes, we should worry about climate change, but we also should not be too alarmist, because there's going to be idiosyncratic shocks to different places on Earth. If we can trade with each other, that's a major mitigation strategy for at least as far as food security is concerned. Thanks all. That's it from me. I'm happy to.
Okay. Thank you very much, Professor. So we have 7 questions. So I want to quickly ask to you. And the first question is yes. Can we identify parallels to modern trade under environmental or logistical risks?
Yeah, I mean, that's exactly what we are trying to do. In some sense, what we did could be done one-to-one for modern trade as well. And if anything, we have better weather shock data today. Again, 101 level import demand, export supply, textbook case for trade should be validated. Somebody should do it with modern day trade.
Okay, I pass the second questions. So, how does this perspective challenge or complement traditional explanation of trade barriers, such as a tariff, infrastructure, or political institutions?
So we do bring, I guess, a historical narrative to all these. Let's talk about political institutions. If you have an export ban, right, that's like one of the most rigid trade barrier. We have seen that, for instance, when you look at the COVID period, there were export bans out of Russia, out of Indonesia for rice. As I alluded to at the beginning, one of the first instincts of policymakers is always to restrict trade or to resort to protectionism.
Okay, we have the one questions, but I think this question is a merge. So first of all, I want to ask the first part. What kinds of technological, organizational, or logistical innovations might have emerged in response to weather risk in early modern maritime trades? So, do you want the second part?
Let me address read me the second part. Yeah, you're right. Maybe they
Okay.
can be
The
merged.
second part is how can these historical adaptations inform our understanding of the resilience and innovations in contemporary trade systems?
Yeah. Okay. Great question. First of all, this period is at the tail end of what's called the Little Ice Age in Northern Europe. From 1400s onwards, the several hundred years, 200 years, weather was depressed. It was colder than average. It was like a mini ice age. And there's quite a bit of historical narratives of how, especially the low countries, the Dutch and the Belgian cities, it impacted these places majorly. First, it was a negative shock, but then in order to survive, both institutionally but also in terms of developing these trade relationships, securing food sources, making sure that credit is maintained, they were quite innovative. So if you search Little Ice Age, adaptation, the Dutch, there are a couple of really well researched books with data. It's a fascinating social history or political history of adaptation. In all these cases, there was both technological as well as institutional adaptation and resilience. So I think, again, that's the positive message. With climate shocks, I do believe in human ingenuity, and both trade and technology will go a long way in helping us to get through this.
Okay, I pass the next questions. What does the study suggest about the role of the environmental risk in shaping long-term patterns of economic development and international trade?
I must mention there are a couple of recent papers that use the sound toll data to study related questions. One of them is on the shocks to cities. So, what happens to cities that are shocked by the plague shock? If they have better established trade relationships, they do better in the long run. So there's this well-known fact: things are very persistent in urban history, like the size of cities, their rank in the ranking of city populations is quite persistent over centuries. So if you can weather a major shock because of either resilience or better connections, then that gives you a long-term advantage, a long-term boost. So we do see that in this period as well. I would encourage the person from the audience asking this question to look for the couple of other papers that use these data sets for other outcomes.
Okay. So this questions is a link to the first questions is this same. Can lessons from the Baltic Exchange inform policy or business strategy today, particularly under climate change or other systematic risk?
I don't want to repeat myself. I think I iterated that a couple of times. But good question, of course. Yeah.
Okay.
That's the whole point.
So the last question is, despite the early use of these canals in Europe, why didn't colonization occur? Consider, for example, trade routes or ways to India or South Africa.
Well, this trade is called the mother of all trades. It was going on for a much longer time because it was an easy sea to navigate, right? For colonization and long distance trade, there had to be major innovations in maritime shipping, and that happened. And different commodities were traded. But as you see, until the grain invasion from Americas, Russia and Poland were major sources of grain for Western Europe. We
Yes.
do, where maybe sort of another takeaway for the Turkish audience. Of course, historically, trade in Mediterranean was very important. Maybe, the cradle of civilization. But we are relatively ignorant about this really important trade in the north. So the Baltic is like the Mediterranean. It's a really easy sea, and it connects these very heterogeneous areas, West and East Europe. It was very, very, very important for the economic development of Northern Europe throughout centuries.
Okay, Professor, all of the questions is finished. So if you want to say anything of the end of the sessions.
Thank you very much, Yasin, for organizing this. Wherever the audience is on Earth, I say merhaba and teşekkürler, and I hope
Yes.
I can attend this in future years and see others present.
I hope.
Yes.
I want to every year I invite you, but sometimes happens, sometimes not happens. So just I will try these
Absolutely.
invitations. Yeah.
Stay in touch.
So today, on the last day of the Congress, we were with Professor Kerem Coşar from the University of Virginia, and we will review his article, The Baltic Exchange, Weather Risk and International Trade in Early Modern Europe. And thank you again for your participations and contributions, Professor. So this concludes these sessions. I will see you in the next year. Stay tuned.